Dirty data can take such a wide variety of forms, and the downstream effects can really take on a life of their own. From users and their seemingly ever-increasing finger size to unexpected changes to that API you've been using for over a year. Dirty data can creep up on you from just about anywhere. Even worse is when decisions are made using bad data. Here to hopefully shed some light on a problem that affects everyone in technology at one point or another is someone we're very lucky to have at ETE and someone I'm genuinely honored to introduce. Associate Professor at George Mason University's Department of Information Sciences and Technology, a decorated Vietnam veteran, a competitive table tennis player, an amateur astronomer, and I'm sure that's only the beginning of the list, Harry Foxwell. Thank you for your service, Harry. Take it away.
Sure, thanks. So let me share my screen. All right, can everybody see that? Okay, and you can hear me okay? All right. Okay, well, number one, thank you for inviting me to talk at the conference. One of my favorite topics of data analytics, which I teach at George Mason University. So let me add a little bit of information here. So I develop and I teach data analytics courses at the College of Engineering and Computing at George Mason. I've taught this one for several years. I actually joined George Mason in 2017 as a full-time professor. Prior to that, I worked in the industry. I worked for Oracle, Sun Microsystems, and other companies that probably no longer exist. And some of you may not even have been born at that particular time. I worked for a company called Digital Equipment Corporation, which some of you may know about historically, but it's no longer around. It was a very large company and no longer exists. Interesting lesson there. So I teach a course called data analytics, and the syllabus is there if you're interested in looking at the syllabus for that. And I also recently started teaching a course in big data on cloud computing using Amazon Web Services. Very, very interesting course, particularly challenging because Amazon keeps changing the academic material that they provide for use in their courses. Very, very interesting amount of technology there for data analytics. So I'm going to make some assumptions about the people that are listening to the presentation here. I'm going to assume that at some point you know a little bit about programming in Python, because that's the one I'm going to use for demo. If you're a beginner, that's okay. If you know some other language, that's okay. And if you're an expert, that's okay. Although I do admit I am not a completely fluent and expert in that language myself. So I am going to talk a little bit about understanding the environment in which you write programs, or IDEs, interactive development environment. I'm going to use something called Spider. We use that a lot for demonstration programs in our courses. So understanding the IDE, understanding a little bit about the basic syntax of Python, which is not a very difficult language to learn, and about the libraries that you load into it to do special functions. What I'm going to be talking about is not unique to the Python language. There are other languages that can do data cleaning and data analytics, summary statistics and visualizations, things like that. Probably the other one that data analytics professionals use is R. But people that use Java and C and other languages can also do these kind of tasks. It's just that you kind of translate it from one format or syntax to another. I'm also kind of assuming that most of the listeners haven't had any data analytics coursework here. What that means is you will probably be given tasks to clean up some data, possibly without some background in the nature of that cleanup and what the impact is on the data. So you have to be careful with changes that you make to data. And I do recommend that if you are cleaning something up, you go back to the original generator or owner of that data to make sure that you do the right thing and don't change things unnecessarily. The examples that I'm going to use are fairly basic and common. I don't claim to be they are the most elegant or best Python practice. These are for students primarily who are kind of just beginning in data analytics. But ultimately, the concepts of what has to be cleaned and why are embedded in the examples. And the example is kind of fairly short, just a few particular lines of code to show particular tasks that will clean up some data. So I'm assuming that you can kind of integrate those code fragments like Lego blocks. Take the particular code that I demonstrate and put that into the program that you're using for various data analytics of your own. So just to motivate why we're talking about this particular topic, we want good data. Good data allows us to make good decisions. Good data has to be accurate. It has to actually record what you're trying to capture in whatever examination or exploration you're trying to do. So if I say I want to measure somebody's height, and they're 72 inches tall, you don't want to write down 41 inches, okay? But I have to make sure that the data is actually correctly recorded. It has to be relevant to your goal. It has to be representative of what you're trying to measure. So if I want to say, oh, how tall somebody is, I can't just simply use words like tall and not so tall and short, but I actually have to use a measure that actually reflects what you're trying to capture for the relevance to your research. You have to have something called metadata, a data dictionary, something that explains what the measurement is and what the units are. It should cover the cases that are involved in the thing you're trying to investigate, and it should be a sufficient range and detail to give enough statistical and relevant measurement to answer the questions, your research questions of why you are collecting the data in the first place. And this chart is kind of an interesting generic discussion of the impact of bad data. Okay, so if you get bad data, discover your bad data too long after you originally acquired the data, the problems of fixing the bad conclusions that you drew from it is much more expensive than trying to correct it earlier, or possibly even making good data in the first place, which is one of the things I wrote in a short book that I'll talk about later. But the power of 10 increase here, prevent it, cost is very low. For correcting it, costs some money to do that, and in fact, it may take a long time to get your data cleaned up before you're even allowed to draw some conclusions from it. And if you discover, like I said, if you discover it at the end that your conclusions and decisions have been based on bad data, that could be very expensive to correct. So lots of different ways you can get bad data. You can have a poor design in the actual data collection process. You can not have a good clarity about the definition of the data that you're trying to collect. So pre-collection problems are very common. In collection, typically it's human errors of some kind, poor instructions to the people that are actually conducting the data collection, or the people that you've instructed to collect it. All kinds of recording errors, typographical errors, and things like that. We'll see some of those in the example. And then once you have collected the data, then you start messing around with it to copy it, make some transformations of it, and that can actually mess up the data as well. So a lot of different ways to mess up your data. And again, the point is we much prefer to do good data in the first place, but the typical problem that's handed to a data analyst, or sometimes even just a programmer who happens to know how to program and make these corrections, you just say, well, here's some data that has some errors in it. Please fix it for us. So the kinds of things that we see in examples, we have, as I mentioned, incorrect data. Typically, it has to do with the units that people use. So they misuse data. Measurement units, sometimes they include it incorrectly. It's actually not good practice to actually include the data units in the data recording itself. You should put that in the metadata, in the data definition, and basically say, well, the number that you see here, it refers to in the metadata a particular unit of measurement, like time or distance or some physical measurement. And there are many examples of misuse of data that actually have caused some serious problems. If you go down to this link here when you have a moment to take a look at the presentation, one of the most expensive ones was a Mars orbiter that went to Mars and did not collect what it was supposed to collect because of a unit error between standard units and inches and centimeters. Actually missed its target. Actually missing records and values, that's a very, very common thing. How do you fix that? I'll mention a little bit about that in the programming example. If you're recording data, we still use the standard QWERTY keyboard to record data, and often we see sometimes people put the incorrect letters for numbers and numbers for letters. So we use L and 1 can be very, very difficult to distinguish from each other. If you take a look at the example that I have on the screen here, you have to kind of stare at that to see that there's a little tiny bit of difference up at the top of that 1 and the L to make a distinction between the two of them. So they're kind of difficult to see sometimes. And also the difference between 0 and 1. Oh, I'm sorry, 0 and O. That also is dependent upon fonts, and in some fonts they look very, very close to each other. Other errors that can come up, people when they're typing things in, they sometimes do transpositions. Instead of 23, they type 32. And then when you're collecting data and you're not given good instructions about how to characterize something, if I say what country is your citizenship, some people might say USA or US or US of A or United States. And so there's no consistency in the collection of the data. So consistency problems also creep in to data. We call that a dirty data problem. So there are lots of data cleaning methods, and the ones I'm going to focus on are the programmatic ones. Visual inspection, if you have a very smallish data set, maybe something on the order of about a dozen variables and maybe a couple hundred at the most records, you can kind of scan that with your visual system and see if you can pick up any problems. And it's kind of easy to miss the typos, especially the things like the font dependent errors that I showed a moment ago. And you can fix that then. Just load the data into a text editor and then do a search and replace. So that's the easy thing to do if you've got a small data set. As the data set gets bigger and bigger, then it's kind of harder to go through the process of visually scanning it to see if you can find the problems. So there, you need some computational assistance, what we call programmatic scanning of the data. And for that, you can use a variety of different tools. We can use Python, the R programming statistical language. You can use SQL, you can Excel, and also some operating system tools, which I'll remind you about a little bit later. And you can use these tools to kind of scan the data for errors of various kinds. You can also programmatically fix or replace data and discover issues in the data that might be difficult to find just by visual inspection. And then when you get to what people today are calling big data, really huge data sets, petabytes, exabytes worth of data, things like gathering data from social media that's generating literally gigabytes of data per second. That kind of stuff, if you need to get some corrections of the data in there, then you need some help. For that, you use artificial intelligence attached to some of these commercial products, machine learning techniques. And some of those are starting to work their way into commercial products. Tableau is a nice product for graphing data, and it's starting to have some data cleanup tools built into that. Amazon Web Services for big data exploration has a tool for converting and inputting data and scanning it and correcting it as it comes in. Same thing with Oracle. Oracle, the large database capability, and Oracle also has an ability for cleaning up and detecting data errors. But I'm going to focus for our little talk here on the programmatic piece. And there are things that we can fix in that methodology, and there's things we can't fix. We can fix things like, well, if data is missing, we can delete the records and not worry about those records that don't have the information in it that we want. We can replace the missing data in some way with a technology called a methodology called imputing the missing data. If we see duplicate records in our data collection, we can figure out how to get rid of those duplicate records. We can make corrections to the inaccurate data values, like we saw with the the O and the 1 or the L and the 0. We can make those kind of corrections. We can even correct things like inconsistency. So if I say I'm in Fairfax, Virginia, and I say in my data set that my location is Fairfax, Virginia, and my zip code is 17603, then I can have a mechanism in there that checks the locations against the zip codes. The post office does this all the time and can discover inconsistencies there. So you can program those if you have a library that has the ability to check things like zip codes and city agreement. Things that you can't fix. Can't fix bias. So if the data is collected in a biased manner or by poor design or by incorrect definitions of what the data is, or even the data expires in some way because you've taken too long to collect the data and then start analyzing it. Those kind of things we can't really fix programmatically. We have to actually fix the methodology of the of the data collection. And again, this goes back to make it right the first time, or you're going to have things in there that you can't fix. Bias is a really, really big problem, especially related to the previous talk when you start putting bias data into artificial intelligence and machine learning, and outcomes are detrimental to decisions about people that are affected by AI. So, in using Python, there are some commonalities in the data analytics approach to cleaning up data. You actually have to load in some libraries that are used for various kinds of variable transformations, if you will, and data structure creation. So there's a library in Python called Pandas that allows you to create data structures for analyzing your data, which includes things like what they call CSV, comma separated value files, or it can read in data from databases or from the web or from other formats, HTML, things like that. So you need to bring in data and have some structure to it. So that's what the Pandas library helps you out. The NumPy, numerical Python library, for any kind of computation or transformations that you want to compute for your data. There is a regular expressions library, which can be used for scanning character strings for various repetitive patterns or things like that. I'll show you an example of that. And then, of course, it's always a good idea to make a picture, because pictures are a little bit easier to understand with the analysis of data. And visualizing your data is a lot better sometimes than staring at a collection of numbers and figuring out what's wrong with that. So we use the programming approach, the programmatic approach, for discovering issues in the data. I call that finding, mostly for dealing with things like missing values, typos, discovering outliers, unusual values. And then there's the cleaning piece, which is separate. First, I can simply say, well, here's a presentation of a data set, and here's all the things I found wrong with it, but I didn't do anything to fix it. But then there are other parts of that process where you can say, okay, I want to clean it up, I want to fix things. What can I do in that? But that second part there, the cleaning part, if you are just simply a programmer who has been given this data and who's been told to clean this data up, then you need to make sure that if you make any changes to the data, like replacing values or deleting things that were collected, you make sure that you check back with the data owner before you actually start changing the data. Because if you change the data, you're actually changing the research results that the owner created. So I'm going to use a IDE called Spider. Very big common one for doing Python programming. It's also very good for teaching Python. So that's one of the reasons I use that in my class. So I'm going to use Spider for the demo. I'm going to use a synthetic data set. Synthetic meaning I kind of created it just for the demo, and I used a tool called Mankaroo, which is a very nice a tool for generating large amounts of various kinds of data just for practice. I recommend taking a look at that if you have a task of generating test data for something. And all of the material that I've covered, that I will be covering here, is in this pointer here to a web page I just recently created. The data set that I created, which is called dirtydata.csv. All right. It has a ID number for the record. It's got the first name, last name, a person's age, their gender, their world citizenship, and what college degree they have. So just a sample data set for that. And then let's take a look at the programming code. And don't be confused or intimidated if you haven't programmed before. And if you've seen and you've done a lot of programming in Python before, please be forgiving in the your commentary about the the nature of the code that we have here. So whenever you have a programming tool, often you have to load in libraries to enhance that tool. So we first import some libraries into the Python code. We import an operating system library so we can manipulate and navigate directories. The pandas library I just mentioned. In the Spider tool, I have to expand the ability to display the code in this other window here. So I'm going to have to say the rows and columns that I can see in this other window. I need to expand that a little bit. And then I'm going to load in my visualization library called Matplotlib, very, very common one. There are many, many others that you could use to enhance the plotting ability, but this is probably the basic one that everybody kind of starts off with in their coding. So I'm going to run each of these one line at a time. All right. Change directory to the place where my dirty data is located. And let me see if I can blow this up for you so you can see it. All right. And then I'm going to read in the data set. And this is a comma separated value file with a separator as the semicolon. All right. So just as a reminder what that looks like. All right. A CSV file is not always comma separated. You can change the separator to be a tab, some other value. Sometimes people use a vertical bar. I'm using a semicolon here just as a substitute for that. All right. So I'm going to read that data in, and then I'm going to display it. So you always verify that you read it in properly. And so there is the data. All right. And a visual inspection of this already shows some issues with the data. So for example, I see college degree is supposed to be MS, BS, or PhD, and it's supposed to be these letter abbreviations here. And somebody put in, a PH.D. for the value for PhD, which is inconsistent with what the other data is. So that's one thing that has to be fixed. Same thing with gender. I see some M's instead of males, okay, F instead of female, okay. So I've got some problems with this data set, and the problem then is how do I fix that stuff? Well, first part is how do I actually discover those issues? So one thing I do in checking data is to see what kind of data types has been imported into the tool, into Python, and when I do that, I see that these things called objects, which are basically character strings in Python. So everything that got imported turns out to be, according to this data set that Python just brought in, turns out to be an object. However, age is supposed to be a number, and it's being interpreted as a character string. So I got to figure out how to fix that. Okay, so we'll see what that looks like in a moment. So if I actually try to do a summary statistic on on age, which should give me things like averages and maximums and minimums, then when I try to do that, it turns out that There we go. It turns out all it gives me is counts and other things. It does not give me what I expect for descriptive statistics, which is the simple things like mean, maximum, minimum, and stuff like that. So I'm going to check out a couple other things about what's going on with this data. So I want to see, number one, is there any missing values in the data set? So the is not available function from the pandas library. And I run that. And this false means that a data item is not missing. But if I scan through this, I see that I have some values here where, yes, I do see some missing values. So I can want to see perhaps what those values are associated with. So I can say, let me see how many variables are there and how many of them have missing data in it. So first name looks okay, last name looks okay. Age has a missing value in it. Gender and citizenship look okay, and college degree has a missing value in it. So I got to fix those things or make a decision about, should I fix it? Should I just throw the data away? What should I do to address that problem? Also, another problem might be something like duplicate records. So if I display my data again here, right, I see that my last records here, they seem to be all the same. They're duplicate records. So how do I, take a look at cleaning up duplicate records? Well, there is a function in Python for dropping duplicates. So if I just say run that and replace the data set with a data set that has the duplicates dropped, or run that. So then display that data. All right. Now you can see that last listing is no longer the duplicate record that I had up here. All right. So that's another thing you do. Okay. So we're cleaning things up bit by bit. We're getting rid of, or at least discovering problems and starting to correct them. All right. So I'm going to create a new data set called ddata2 by dropping those missing records. So here's the way to do that. There's a function called drop NA in Python that says just drop the records that have missing data in it. So I'm going to do that and then display that. And now I have, if you remember, there was some missing data in that we no longer have that in that data set. So now I can do some additional things. I can check to see that we have a data set that doesn't have any values that are marked as true for being missing. Okay, so that looks like it's pretty clean. And I add up the values to see if there's any missing values indicated there. Nope. All right. Now, if I go back and try to do my summary statistics on age, for example, I still get not treated as a number. I'm going to need to fix that. In fact, if I actually run the code that says check to see if there's numeric values in this data item called age, actually, if I do that, all right, it turns out that I have some false values in that data set where the data is not being picked up as a number, which is what you need to do to do your summary statistics like means and maximums and things like that. Now here, some visual inspection tells you what the problem is, okay? If I look at this right here, I see 3, 1. I see what a 1 looks like, okay? That the top of the 1 is kind of tilted down a little bit. Here, I see this does not look like a 1. It looks like actually a L. So that's something that has to be fixed and replaced. Now, one way to fix that is programmatically with just running it through and finding it and replacing it. Or the other is if the data set is small enough, you just go through and you fix that with an editor. Same thing here, okay? This looks like 30, okay? But here is a 0 as it comes out, so with a slash through it. This does not have a 0 or a slash through it. So obviously that is the letter O, right? Yet another thing that needs to be fixed. Right. So those are kind of things you have to fix and observe and find other ways to discover. So again, the discovery tools in Python let you do that. Let's take a look at a different variable, college degree. So there's all my college degrees. All right. And if you remember, I had a misrepresentation of that value up here. Instead of PhD uppercase with no periods, it's got this here. So we need to fix that. So, and again, if I want to discover those kind of things, see how many of those things are in there. Well, if I run the code again with the count to see how many values there are, such like that, I've got 35 PhDs, with the PhD uppercase, no periods, 34 MS and 29 BS, and then I've got only one of those things that needs to be fixed. So I can fix that by saying, well, create a new data set with the replace function. So replacing things in a programmatic way, there's always character strings that can be manipulated with the various libraries in a programming language. There's a replace function in Python. So I can just simply say replace when you see the this particular character string, replace it with another character string. I can do that over and over again with other kind of errors that I see in the in that data set. So there, I think there is a warning about that particular value, but we're not worried about that later. And then we have repeat to see the counts to make sure we have everything corrected. So we have 36, 34, and 29, where we had that other one incorrect earlier. A couple other things we need to check, the value counts on gender, as we saw when we displayed the data, all right? So we see that there are a number of different errors there, okay? We see a lowercase f for female, a F or an M for male and female, which are incorrect. You got to fix those too. You can fix those with a editor, or you can fix them with the same kind of thing we did up here with the replace function. I went through and I did actually clean up a number of things in the data set. So what happens should you look at when you actually have a data set you think is clean? So let me load in a different data set here. I call it undirty. Load that in. And then look at the data types. And I see my age is at the integer 64. So now that's the right thing that I expected to see in there, okay? And now if I get the listing, now remember, this is supposed to capture numbers, right? So if I now do another form of data scanning to see if the data is correct. If I say, give me the description of that data, then I see, and I'm going to round this off because when you see too many digits here visually, that kind of makes your scanning for errors a little bit more problematic. So I'm going to round this off using the round function. All right, and now I see I've got 99 values. My mean is 47. My minimum is 2, and my maximum is 132. So clearly for ages, these are errors. So again, this is yet another methodology for discovering errors in your code. Generate simple, most people could understand these statistics. You don't even have to be a data analyst to understand these stats, to see if there are sensible values in your data set. I can use a technique called a box plot to picture that. That's using the visualization library I mentioned a moment ago. So there's a box plot which actually shows that extreme value here of 132 and a value down here close to 0, which means, okay, this is a pictorial way of discovering the data. You can generate box plots on any numerical data item and explore and find extremes and missing data. Now, you have to be careful when you are thinking about, well, let me fix or getting rid of outliers. Clearly, there can't be a 132-year-old person, and clearly there can't be a 2-year-old person in this particular data set. But suppose I said there was a 100-year-old person. Okay, is that an error or is that a real person? You don't want to throw away good data, and maybe actually you're actually discovering something interesting. But when you see an extreme value, an example I use in my class is there's a data set from the Department of Labor Statistics of how old people are when they get their PhD, and I come out as a outlier at age 55 when I got my PhD. But in that data set, there's actually 100. Actually, did somebody actually get their a PhD when they were 100 years old, or is that an error? Turns out there was an interesting story behind that. There was a person in World War II who was prevented from getting their PhD, and they finally got it when they were 100 years old, and there was a nice little story in a newspaper about that. So data can be correct even though it looks like an outlier. So that's something you have to consult with the data collector about things like that you find. One other thing to do before we get back to our presentation. What are you doing on time here? Okay. So let me read in that data file again. And check to see, do we have any missing values? I don't see any missing values. Whoops, yes, there is a missing value, okay. So let's see where it is, all right. It's in age. Okay, I kind of put it back in there after making the correction. So one thing that we can do is we can use a technique, which I caution against if you don't know what you're doing, but it is a technique that you can use to make corrections in data. If, for example, you have a whole bunch of records and you don't want to throw away, good data in that record simply because there's one missing value for a variable in that, you can actually fix that with a technique called imputation. So you can say, I want to replace that value, that missing value, with something that makes sense. Well, what might make sense? Well, I could just simply put an error code in there, call it 0 if I want to, just say that anything that's a 0 is an error code, and I have to figure out what to do with that later. Or you can say, I want to put actually a reasonable replacement in there. How do you do that? Well, one thing you can do is you can say, I want to replace it with the mean or the median or some other, sensible value. So one thing that I can do there is I can do a function in here called first find the mean. Okay, I'm going to say, let's find the mean of that age value. All right, and then I can in place that data item with that value, and that is called a fill NA. Fill the missing value with something that the function lets you do, and I can fill it in with the thing I just computed. I can fill it in with the mean and put it in place inside that data set. And then when I do that, and then I check to see if there's any missing values in there. All right, there's no more missing values. All right, and then I can continue on and do my summary statistics and things like that. So that's a very, very quick overview of the kind of things that you do to look at, to discover, and possibly fix data items. Let's go back to our demo here, or our presentation. Other kind of problematic data. Sometimes you are acquiring a data set or given a data set and you find interesting problems in the data. So let me show you this particular interesting data set from the Hurricane Data Center in at NOAA, okay? And I use this as an example data set in my class. So here's some interesting data. Okay, I've got year, month, states affected, the category of the hurricane, the pressure, the maximum wind. One thing that you might have to do as a data analyst is to say, well, here's data that's presented to me in a HTML page. I want to be able to scrape that off into a format that I can analyze with Python or with other languages. So we use a technique called screen scraping to do that. But one problem we saw with this data set was the way that the data was presented in the states affected. Okay, so here we would typically have, we would want to have a simple, listing of the states affected. But here we have all these codes. Okay, so how do I know how to count up the data in this particular column based on state? Well, I have all these symbols here. IGI, you've got NE1. What does all that mean? Well, you go all the way down to the metadata down the bottom, and it explains all that stuff. Okay, it explains all that stuff. However, the problem there is that whoever designed this data set used this compound data item, which is much more problematic in trying to compute and find out where all the data items for each state were represented. So that's probably a problem where you don't want to create data like that. You don't want to put complex data items inside mixed up with single value data items. That's one problem we see in data analytics. Dates and times are always problematic because people, when they write down their name, their dates in different countries, they have different formats. So if I say, what's today's date? we sometimes say it's 419 2022, but that does not sort properly if you're just looking at the the representation of that. Probably what you want to do is use kind of standard format, like 2022 dot 4.19. That would sort properly. So data that is in times and dates and things like that need to follow a standard format. So if you have to fix that, there's some modules in here in Python to help you do that. Other programming languages let you do that too. But best idea is to make sure that when you collect the data in the first place, you put it in some standard form. And then there are all kinds of data sets that you can get your data in. The CSV, which we just looked at a moment ago, you can scrape the data off in HTML. There's JSON files, structured XML files, spreadsheets, databases, things like that. And those are often problems that you have to figure out how to extract the data and do some cleanup on top of understanding the format that it's in. And one interesting problem for programming is that if I see a data set with that somebody put in a spreadsheet, they put titles on their spreadsheets for the data columns, and they can put all kinds of evil characters in there. They can put ampersand signs and slashes and other kinds of things. Those are not proper variable names inside of a programming language like Python. So sometimes you have to make a correction to import the variable names properly or change the variable names when you do that. And then, of course, the delimiters that define the records, you have to make sure that you are using a delimiter that's not part of the data. Because if you are bringing in a data set that has commas in the data items, you can't use a comma for the delimiter when you create that data set. So all kinds of problematic things with data sets as well, not just the data inside it. So what are some of the recommendations? And then I have a couple little interesting things to show you here in a moment. So number one, if you're analyzing data and it doesn't come with a record number, make sure you put one in there. You can put one in there in a variety of different methods with various kinds of data tools. And I want you to say, don't assume that you have to use a programming language to analyze your data. You can use operating system tools, right? And I'll show you what they look like in a moment here. But the operating systems, in particular, Linux and OS 10 come with some very, very nice data manipulation tools, if you will. And you can get them from on OS 10 from Apple or Linux or Unix. And then there's something called Cygwin, which is these libraries of OS tools that you can actually install on Windows if you're still one of those people who use Windows. But the process of cleaning up data is iterative. You don't stop, okay? You just basically clean it up, scan it, repeat it until you make sure you have a good data set. Typically this is an asymptotic process, okay? You discover things over and over and over again, more and more kind of data problems in a large data set. And ultimately, you're probably, shooting for perfection, but it's kind of hard to get sometimes because all different kind of problems could be in a data set. And I like this quote from Edwards Deming, who probably earns the title of the first serious data scientist that started becoming a promoter of good data. He said that the inspection, which is what we've been doing, is checking out, how do you discover problems in your data? He says that's too late. What you really need to insist on is to get the data clean in the first place. And fixing it is going to be very time consuming. And as I mentioned earlier, fixing it is probably going to be most of your time. Then the analytics piece is sort of an afterthought. So just as a reminder about using the operating system and not just the programming tools like R and Python and things like that. The Unix family of operating systems comes with a variety of data manipulation tools. And I use these all the time. I teach my students to kind of learn them, in spite of the fact that most of them are using screen-based, graphics-based environments with OS 10 and Windows. There's programs for looking at the top and bottom of a file called head and tail. Word counts is a program called grep, which is a search functionality. A TR program called translate. There is a sort program in the operating system. You can sort data. There are string manipulation programs, sed and awk. There's a cut program, which selects fields and columns from a data file. There's a unique program, which counts unique occurrences in a data file. There's a program called cat, short for concatenate, which basically says display the data, and I can actually add a little flag to it that says number the data records if you don't have that. And then how do you learn how to use all these things? Well, there's a man program, which stands for manual, and you just say man on a particular data item. For example, if I go over here to here, and maybe I'll say man for the cut program, and there's all the information about that particular program. So there's documentation built into these tools. And then you can actually take the output of these programs and pipe them into graphical tools, which typically come with or can be installed on things like Linux and OS 10 and Unix. So there's graphical programs, XGraph and GNU plot, so you can create visualizations out of these. Just a quick demonstration of how this works is I'm going to take a look at this dirty data data set. I'm going to search for all the males in that. I'm going to select the column 7 out of that. That's the PhD, MS, and BS column out of that. Sort it and count up the result, so I can see if I can discover any issues in that data. Where are we at here? Come on. Oops. I thought I had that. Hold on a second. So let me just copy this. And where am I at? I'm here. Okay, so don't you love demos? They're supposed to work. Yeah, dirty data should be there, right? Why is it not finding that? Well, I will have to find out what's wrong with that later on. I did have that pre-set up. Let me just try one more thing.
Someone suggested that copying from PowerPoint might be messing
yeah,
up
that's usually a problem with the quotes. So I often have a difficulty with that. So let me get this out of the visibility for the moment. And see if I can make it work this time. There we go. Okay. Again, copying from odd fonts can be a problem. And okay, so here we go. I said display the file, search for a value, pick a extra column out of that data set, sort the results, and count the unique occurrences. And here I have the values for the bachelor's, master's, and PhD, and I discovered in this process the missing values. So I didn't have to do that with Python. Okay, I didn't have to do that with a visual search. I can just basically use a operating system tools. So I highly recommend taking a look at operating system tools as an assistant to the programming piece. Okay, almost done here. All right. So there are a variety of resources, and to be perfectly honest, there are other books besides mine that are available for people that want to do data cleaning and data exploration. So mine is Creating Good Data. It's a short one because my students have a short attention span. So it's a nice short book with a lot of interesting little pieces of data cleaning advice in there. A longer one from O'Reilly for probably more professional programmers. And then the data cleaning one from the ACM is a more of a higher level approach to cleaning data on a larger scale. A lot of the data cleaning that they talk about in this book has to do with using AI and machine learning techniques for cleaning data. So, depending upon where you are in your data cleaning knowledge and background requirements, so you can find something that's easy and quick, something a little bit more relevant for people that are data analysts and doing that, or for computer science and AI and machine learning tasks. Then the latter one is a pretty good one. So I'm going to use the rest of the time here for any questions that people have. I will remind you that nothing in this is proprietary. So the code itself is in this website. In fact, I can call that up, I think. All right. So the presentation is here. The dirty data file is there. And the code to read that is in there. And there's also a little bonus in there, a presentation called The History of Data, which kind of gives you the idea of how important data is in the world, and historically how data analytics has saved lives and created opportunities for momentous discoveries. So let me now go to, I think.
So I was going to say I can.
Yeah, I want to go
easier on you.
Yeah, I want to go to the. Where is that? I want to go to the Slack. Okay, so we have some questions. So let's see. So with the advancements in AI, how practical is it to write one super algorithm to handle data cleaning? Well, there's such a variety of errors, and the question then comes up is, how do you create a let's say a thesaurus of errors that can be used to then make a decision about a standard way of cleaning them. All right. So in the example that of the PhD example, PH dot D dot versus the uppercase, the algorithm probably could discover that. However, in the case of the letters for numbers, probably there's something that can help with that, but there may be some ambiguity in there that would have to be fixed. So I think there are algorithms that certainly help, and in fact, some of them are already built into commercial tools for loading data and discovering, or at least warning you about errors that are in that data set. So I would say, is there one particular super program that fixes your data completely? I would say probably something that would clean up, a fair number of errors, but not everything. Jeremy, have you come across a novel way to handle the metadata layer or data catalog? In what sense? I mean, you have to have a good description of the data that makes sense to the people that are gathering the data, creating the data. You don't want to be ambiguous in your instructions. So metadata has to be complete and clear and unambiguous in describing your data items. The numbers from your group look too high to me for just males. So grepping for male matches female. Did I not capitalize? Oh, I'm sorry. You're right. You're absolutely right. Okay, I had the grep minus I in there. Good catch. Okay, so if I was going to do this again, I would say don't do a ignore case search. Okay, then I would only catch the entries where you have uppercase M for the male. And you're right, you're absolutely right. If I do that, then I get the correct numbers. Very good. Yes, okay. Evan, you are absolutely right. There are various additional flags that you can use to search for characteristics of characters in a character string. So yeah, you can search for beginning of line. There's a let's see if I have it handy here. There's a whole bunch of things on regular expressions. Okay, regular expressions. You can do beginning of line, end of line, various characters and counts and things like that. So that usually comes with experience with programming in Linux or Unix or other environments to support those kind of regular expressions. But thank you. That was a good catch. So let me go back to my Slack here. Okay.
I did just want to give one heads up that the meeting will automatically end at 11:15.
Okay. All right. So we have time for one more question. What process or tool do you use to record any manipulations to the data, or is the Python script you have crafted? No, I didn't put any lineage capturing in that. So you can either do a sort of a manual process and document what changes you made. The automated tools that I mentioned, some of those actually record any of the changes, but you do have to capture the changes that were made. The lineage of a data is certainly very, very important. I have not experimented very much with those kind of tools, but you're right. That particular task of capturing what changes were made are very, very important. Well, since we're finishing up in 30 seconds, let me thank you for listening to the presentation. I hope it was informative to people. And if you have any questions or comments or suggestions, please send them along. There's my email address down here. And a little bit more about me is in this link here. So thanks again. And again, thanks to the organizers for inviting me to talk about this.